friends, myself Rahul Kotkar and I am going to teach you subject physics. Okay, we have to start with the chapter number 1 from standard 12, that is rotational dynamics. Okay, so friends, first thing, what is the rotational dynamics? So remember carefully, this chapter is the combination of circular motion and rotational motion. Okay, as from the previous syllabus. So we have to first understood the word dynamics. So this word dynamics, okay, can be explained by using a simple definitions which we already studied in standard 11th. Okay, so what is the dynamics? For that we have to study some definitions. First definitions that I am going to explain, that is the mechanics. Okay, so the branch mechanics which comes from or which deals with the study of motion of an object. Okay, so here the branch of physics which deals with the study of object in motion is known as a mechanics. Okay, means the objects when in a motion, that is studied by the branch which is called as a mechanics. Okay, for example, the car is in motion, a vehicle moving on a road. Okay, so these are the particular examples. So again mechanics have two sub branches. One is called statics and other is called kinetics. So branch statics. Okay, the statics is the branch of physics which deals with the study of object in an equilibrium, that we call at a rest. Okay, means what? When the object is in under a forces, but all these forces are in equilibrium, means the equal forces or the resultant force acting on the body is equals to 0. Okay, then that object is said to be in a equilibrium, and study of such an object, okay, is known as a statics. Okay, so after that the next branch which is known as a kinetics. So in case of kinetics again having two sub branches. Okay, one is called kinematics and other is called dynamics. So what about the kinematics? So kinematics is the branch of physics which deals with the study of motion of the object without considering their cause. Okay, what is the main word here? Without considering their cause. Okay, for example, when a car is moving with 100 km per second, we consider the example. Okay, a car is moving with 100 km per second. So we are not interested why this car is moving with a 100 km per second, what kind of forces are acting on the car. Okay, in this manner we are not interested in all these things. Okay, but we just studied there what is the speed of the car, what is the velocity, acceleration, etc., etc. All these things are studied in this branch called kinematics. While in case of dynamics, dynamics is the branch which will branch of physics which deals with the study of objects, okay, with their causes, or which describes the motion of the object with its cause. Means a car is moving with 100 km per second. Why the car is moving with 100 km per second? Which force is acting behind it? What is the reason? Okay, all these things are studied under this branch called dynamics. Okay, so friends, this is the introduction related to dynamics. Okay, and so we are going to study the dynamics of a particular motion. Okay, so here again we have to study the one more important concept, that is called rigid body. So what do you mean by rigid body? So rigid body is the body which do not changes its dimension under the action of external unbalanced force. Okay, means what? If suppose we consider this body, which is a rigid body, this body is made up of two, just a second. Okay, so this body is made up of a number of particles. Out of that, we consider these two particles. So the distance between these two particles remains constant under the action of external unbalanced force. Okay, whatever it may be the force acting on the body, the distance between these two forces always remains constant, and this is the important thing. Okay, means what? There is no change in dimension. Okay, so this is nothing but your rigid body, and this chapter includes the study of rigid body dynamics. Okay, listen carefully what I am going to say. This chapter is going to study rigid body dynamics. Okay, so again, okay friends, so this is our just basic of this chapter. Now we have to start with the point, that is characteristics of circular motion. Okay, this characteristics of circular motion, it's a very simple. Okay, we first introduce about the circular motion. So what is the circular motion? So circular motion of particle along the circumference of circle. Okay, means what? The motion of the particle along the circumference of circle, it's called as circular motion. Means if this object performing the motion along the circumference like this, okay, the particle performing the motion along the circumference of circle is called as circular motion. Okay, so next thing, so this circular motion have two important characteristics. One is called, this motion is said to be accelerated motion. Okay, this motion is said to be accelerated motion. So why this motion is said to be accelerated? So first thing, the motion is constructed of, okay, the particle performing circular motion having velocity, okay, and this velocity, okay, that is linear velocity, and this linear velocity having magnitude as well as direction, because velocity is the vector quantity, so it have magnitude as well as direction. But the magnitude of velocity, that is called speed, which remains constant, but the direction of the particle performing motion is always going to be changing, and that's why, okay, what we observe there, the direction of velocity is always going to be changing, and that's why what we can say, the velocity of the particle is going to be changes simultaneously. Okay, and that's motion becomes accelerated motion, because acceleration having definition rate of change of velocity. Here the velocity is going to be changed because of change in direction, and that's why what we say, this is the accelerated motion. Okay, another thing, that is a periodic motion, second characteristics. So simple one, while performing the circular motion, this particle performs the circular path again and again in a fixed interval of time, and so what we call, it is the periodic motion. Okay, so we studied the next part again. So friends, we have to start with the point kinematics of circular motion. Okay, so in case of kinematics of circular motion, okay, means we have to study about the angular displacement, angular velocity, angular acceleration, etc., etc. Okay, so first thing, what about the kinematics of circular motion? So we are going to start with the angular displacement. So what is the angular displacement? That's simple, the angle described by radius or position vector when a particle moves from one position to the other position along the circumference of circle. Okay, for example, first I am going to explain what is the radius vector and what is the position vector. Okay, radius vector or position vector. So it's simple. Okay, radius vector or position vector means what? When a particle performing circular path. So in this case, the vector drawn from the center of the circle to the position of particle. Remember, the vector drawn from the center of the circle to the position of particle is called as radius vector or position vector because it is nothing but equals to radius, or it indicates the position, so it is called position vector or radius vector. Okay, so when this particle, okay, now in this case, simple, when this particle performing circular motion, so when this radius vector describes a circular path, okay, means particle moves from one position to the other position, so it will sweep certain angle or make certain angle with the center. So this angle made here, that is called angular displacement. Okay, means the particle performing circular path, okay, or at that time it describes certain angle by the radius or position vector. It is known as a angular displacement. Okay, so friends, again listen carefully. You observe this figure. In this figure you found that when a particle moves from A to B, it makes certain angle theta with the center. Okay, here the two suffix are there, one is called S and other is called R. So what the S indicates? S indicates the arc length and R indicates the radius. So arc, okay, why I am taking arc length as a smaller? So one thing keep in mind, for a circular motion the time t always tends to 0, means we studied the motion for shorter time, very closer to 0. Okay, and for that case the motion of the particle from position A to B is considered as a linear motion, and so we consider this displacement as a arc length as a linear displacement S, and so I put here S. According to the definition of angle, theta is equals to arc upon length, and that is divided by radius. Okay, sorry, I make a mistake. Theta is equals to arc divided by radius. Okay, so it should be equals to S divided by R, and so we can simplify as S is equals to R theta. Okay, so this is the magnitude of, okay, this is what magnitude of angular displacement. What about the its direction? Because theta is the vector quantity, that is angular displacement is the vector quantity, and this vector quantity, okay, having magnitude as well as direction. So this is the magnitude. What about the direction? So direction is always perpendicular to the plane of rotation, okay, and it is given by right hand thumb rule. Okay, we will discuss about the right hand thumb rule in the next session. Okay, so next point that we are going to